How can we make chemical equations more informative? That is what the topic of discussion here. You have learned in ninth class different states of matter. So a matter exists in solid, gas, and liquids. You know that already. And if any substance is dissolved in water, that is called aqueous solution of that substance. So now you have an extra aqueous solution. And temperature changes, required temperatures with delta, and sunlight, if sunlight is required, they should be mentioned on the arrow mark. Thus, by writing the physical states of different substances in a chemical equation, we can make the chemical equation more informative, as simple as that. And gases evolved with arrow marks above direction, and precipitates formed arrow marks down. In that way, we can make a chemical equation more informative. Now, Fe2O3, it is actually process of extraction of iron from iron rust. So we learned in metallurgy. So rust will be in the form of solid. Aluminium, will be in the form of solid. Metal aluminium. After the reaction, you will get iron. So iron will also be in the solid state. And we get here aluminum oxide, which also will be in the solid state. And for this reaction to occur, high amount of heat energy is required actually. So that is why we mentioned the required heat energy on the arrow mark. So first one completed. Now carbon plus oxygen gives carbon dioxide. Nitrogen plus oxygen gives nitric oxide. So here these two are examples for heat change. Heat change means when carbon burns in presence of oxygen, it gives heat energy. As it gives heat energy, the temperature will rise. So as it gives heat energy, so we have to write plus Q on the product side. Right? Now nitrogen plus oxygen. For the reaction to occur between nitrogen and oxygen, they need heat energy. Here heat energy is liberated, but here heat energy is required. So the reaction requires heat energy. So heat energy is observed here. The temperature of the system decreases. That is why we have to write minus Q on the product side. If you are writing plus Q on the product side, write reactance. I think it is clear. So this reaction is called exothermic reaction. This reaction is called endothermic reaction. And so let us write the corresponding states. Carbon, solid state; oxygen, gaseous state; carbon dioxide, gaseous state; nitrogen, gaseous state; oxygen, gaseous state; nitric oxide, in gaseous state. Now other one, zinc. Zinc is solid. H2SO4. We generally don't take concentrated pure H2SO4. Sorry. Now we take actually aqueous solution of H2SO4. Nothing but a diluted H2SO4 we will take. Means H2SO4 dissolved in water. Nothing but it is aqueous solution of sulfuric acid. So when zinc and sulfuric acid reacts, they will give zinc sulfate. This zinc sulfate actually dissolves in water. So after zinc sulfate formation, this will dissolve in water available as the reaction is occurring in water. So and as the zinc sulfate is formed, that after forming zinc sulfate, that will also dissolve in the water. That is why this is also aqueous. This you write here aqueous solution of zinc sulfate. And here we discussed already previously, when metal reacts with acids, that will give corresponding salt and hydrogen gas. So hydrogen gas, you write gas here as well as you keep arrow mark to represent a gas is evolved in a chemical reaction. That is all. Now sodium sulfate, barium chloride, barium sulfate. So if you observe this, so here we will take aqueous solution of sodium sulfate. The reaction itself, we have to form aqueous solution of sodium sulfate. We have to take aqueous solution of barium chloride. We have to mix them. When we mix them, we will get, so you know already, sodium chloride is found here. Sodium chloride dissolves in water, you know already. So that is why, so as there are water present here, so after the sodium chloride formation, it will dissolve in water. So this is aqueous solution of sodium chloride. Aqueous solution of sodium chloride is formed, and barium sulfate. Barium sulfate, in this reaction, a insoluble substance is formed. The insoluble substance, it won't, insoluble means won't dissolve. As it won't dissolve in the liquid water, what happens? Uh, it will be visible to our naked eye, and if you don't, if you keep the system undisturbed, what happens? This will settle down gradually, so it takes long time. Slowly it will start settling down. So, and if a precipitate is formed in a chemical reaction, we have to indicate it with a down arrow. And as it is solid, write as solid. I think it's clear. 2AgBr. So it is silver bromide. Silver bromide will be in solid state if you keep this in sunlight. So sunlight is required. So if it is kept in sunlight, it will decompose into silver and bromine gas. So here silver again is solid state, bromine is gas. A gas is evolved here. So which is gas right here? It's a state, right? G as its state. Is that clear? No. 6CO2 plus 6H2O gives. So this is photosynthesis reaction. For the photosynthesis to occur, you know already water required, sunlight is required, and chlorophyll is required, right? The spelling is wrong, please adjust. So I don't know biology. So 6CO2 plus 6H2O gives what? So CO2 is gas, water, H2O is water, nothing but liquid it is. We got first time L, liquid. We got solids, gases, liquids. So and here glucose is formed gas, and it is solid. Glucose is solid, and oxygen is evolved. So keep arrow mark above showing upward direction, and 6CO2 is gas. So that is what making a chemical equation more informative. So in this way you have to, so by writing the physical states and required requirements, we can make a chemical equation more informative. Here one more thing, there will be a catalyst. Catalyst also should be mentioned above or below the arrow mark, and temperature, pressure also should be mentioned only on the arrow mark. A catalyst, what a catalyst is? A catalyst won't participate in chemical reaction, but it will increase the rate of reaction. The substance which won't participate in chemical reaction, but it increases the rate of reaction. Thanks for watching.